In this video here, we're going to take a look at Kruskal's algorithm. Now, Kruskal's algorithm can be used to find a minimum spanning tree, and this can tell you the shortest, cheapest, or fastest way of linking all the nodes in a network. So, definition time here. A minimum spanning tree, sometimes abbreviated to MST, is a spanning tree such that the total length of its arcs or edges, whichever you prefer to call that, is as small as possible. And Kruskal's algorithm can be used to find a minimum spanning tree. So let's just begin here then by formally defining Kruskal's algorithm. So let's just give a formal definition here of Kruskal's algorithm. So for step 1 then, we start by sorting all the arcs into ascending order of weight. Now that does sound quite tedious, and to be honest, it is, especially for large networks, but that is just the very nature of decision maths. Now for step 2, we then select the arc of least weight to start the tree. For step 3, we consider the next arc of least weight. Now we've got two situations here. So if the chosen arc would form a cycle with the arcs already selected, we must reject it, but if it does not form a cycle, then we just simply add it to the tree. For step 4, we then repeat step 3 until all vertices are connected. And there we have it. That there is Kruskal's algorithm. Now, whether that sounds intuitive or not, that's completely up to you. You might agree, you might disagree. But I think as we work through an example, I think you'll find Kruskal's algorithm pretty straightforward. If anything, just tedious, but like I said, that is just the nature of decision maths. So in terms of an introduction here then to Kruskal's algorithm, that gives us everything that we need. So let's just work through a practice question together. So let's just have a go then at this one practice question here for Kruskal's algorithm. So as the question says, then use Kruskal's algorithm to find a minimum spanning tree. For this network below, we need to list the arcs in the order that we consider them, and also state the weight of our tree. Now don't forget then, with Kruskal's algorithm, the first thing that we should do here is simply list the order of the arcs, right? And we'll do that at the top here. So order of arcs. Like so. So, if we start with the arc of least weight here, that would be this arc here, CE. So CE has a weight of 4, and we'll put the weight in a bracket next to it. Perfect. So, which would be the next arc here with least weight? Well, that would be this arc here, BE. So BE has a weight of 6. Like so. Now, for the next arc here, you actually have a choice of 2, right? Because these two arcs here both have a weight of 7. So it doesn't matter which one you list first, just make sure that you list both of them. So I'll do D first here, like so. This has a weight of 7. And then for the next arc here, that would be BD. So BD, again, with a weight of 7. Like so. Let's just keep going here. So my next choice then is a D with a weight of 8. Like so. And then again, for the final two arcs here, they share the same weight 10 here. So again, it doesn't matter which way you choose these, completely up to you. But let's just do BC first then. This has a weight of 10. And then for the final arc here, this is AB, again, with a weight of 10. Okay, so that's the first step complete here. So with Kruskal's algorithm, we start with the arc of least weight. So that would be this arc here. Let's just make a note then. So we start with CE. Okay, and what I'll do here as I go then is draw on my original diagram here, or my original network. I'll draw our minimum spanning tree, like so. Okay, so we start with CE then. Perfect. And what I'll also do here is I'll take them as I go along. Okay, so we start with CE. And now what we do here is we just go down this list, right? And we just keep choosing each arc of least weight unless it forms a cycle. Okay, now clearly, if we choose BE here, this will not form a cycle. That's this arc here. It won't form a cycle, right? So we include it. So add BE. So we add BE there, like so. And again, let me just do this in the same pen color here, just so we can see it clearly. Like so. Perfect. And again, I'll give it a tick there. So we just keep winning the list here. Again, I'll do it in my original pen color. So I've got DE here. If I choose DE, does it form a cycle? Well, clearly not, right? So we're going to choose or add DE. So add DE. Okay. Again, I'll do this in my red pen here. Like so. We'll give that a tick as well. Now, if I just make a quick point here, right? The original network had 5 vertices. I've got this one here, this one here, this one here, this one here, and then finally this one here, right? We had 5 vertices. So why is that important? Well, what that means then is our minimum spanning tree will have 4 arcs or 4 edges, right? So if you've got n vertices, we will have n minus 1 edges or n minus 1 arcs. So given that I've got 3 edges already here, we're nearly complete because we should have 4 edges within our minimum spanning tree. So let's just keep going then. So BD next, right? Now, if I choose BD, this will form a cycle. So we're going to reject BD here. And it is important that we state this. So going back to my original pen color then, let's make a note here that we reject BD. So reject BD forms a cycle. So forms a cycle. That's absolutely fine there. So we reject BD. I'll put a cross next to it as well. Let's just keep going then. So can we choose AD here? So if I choose AD, this will not form a cycle. Perfect. We're going to choose AD here. So add AD. And again, let's just do this in red here. So if I add that to the original diagram, like so. As we can see then, at this point here, all the vertices are connected. So this here then is a minimum spanning tree. So let's just make a note here. I'll do it in my original pen color as well. So all vertices are connected. All vertices are connected. What that means then is we have a minimum spanning tree. I'll just shorten this to MST, just save me writing that out. So the only thing left to do here then is just state the weight, right? I'll just put a tick next to AD as well, just to indicate that we did choose that. So the weight here is, so I've got 4 plus 6 plus 7 plus 8. So 4 plus 6 plus 7 plus 8. What would this give us here? So I've got 10, 17, 25. Perfect. Okay. And there we have it then. So we've stated the order here of the arcs, right? In the order that we considered them as we've gone there. We've also stated the weight. That's perfect. And there we have it then. So it's as easy as that. As you can see, this is quite a straightforward example. In the next video, I'm going to run through a slightly more challenging example here for Kruskal's algorithm, but you will see in that video as well. Generally speaking, it's pretty straightforward, okay? So there we have it then. That gives the solution here to this one practice question, and that brings us to the end then of this video here on Kruskal's algorithm.